Hello everyone, welcome to our Ask Geology, a whole new way to understand our Mother Earth. So in this today's 7-minute numerical, we are going to discuss about one question that is related to your this is radioactivity, and I have included the isostasy and radioactivity as a different playlist. Okay, so you can find the numerical solution of questions related to isostasy and some radioactivity, but the geochemistry related to your rubidium strontium method and that type of numerical and some conceptual questions will be included in the geochemistry part. Okay, so simple radioactivity type decay, radioactivity decay or stable isotope decay type questions you can get in this session, okay, in this playlist. So this is actually a question from Gate 2007. This is the question number 63. Now the question is asking, after decaying through 7 half-life periods, the original amount of radioactive substance that reduces to an amount of 1 by 64 gram is. Okay, so what is the number of half-life? That is 7. Okay, so for this type of numericals we have one formula, that is n by n0 is equal to half to the power n. This is n is the number of parent atom at time t. Okay, and this n0 is your number of parent atom. This is actually the parent atom at time t is equal to 0, or this is the initial time. Okay, this is actually the initial time, and this n is your number of half-lives. Okay, number of half-lives, and this n is further is noted by t half. This is the time taken, and t half is the half-life. Okay, so what it is asking, that after decaying through 7 half-lives period, that means this is actually the parent atom. Okay, this is the parent, and it has decayed, or it has undergone some amount of disintegration. Okay, it has undergone some disintegration, and what is the number of half-lives? It has gone 7 half-lives. Okay, 7 half-lives. Okay, the original amount of radioactive substance क्या है पता नहीं, this is let x, and it has reduced to 1 by 64 gram. Okay, this is the parent and this is the daughter. Okay, now this x, we don't know what was the amount of atom present when t is equal to 0, but it has undergone some disintegration, or it has just 7 half-lives has been completed, and after completing these 7 half-lives, now the parent atom remaining at time t, that is 1 by 64 gram. Okay, so 1 by 64 is equal to, this is our n value, because this is the number of parent atom present at time t. Okay, this is at time t. Okay, so it's fine, and n0 we have to find out. Okay, n0 we have to find out. Then what is the number of half-life? N is equal to 7 given, so just put these values. Okay, if you just put these values, then n is equal to 1 by 64, it is given, and n0 we have to calculate, that is equal to half to the power n is your 7. Okay, so simply this is 1 by 64 n0 is equal to 1 by 2 to the power 7 is, this is 128. Okay, so simply this 64 n0 is equal to 128. Then n0, what will be the value of n0? This is 128 divided by 64, cancel out, answer is 2. This is 2.0. n0, what does this means? This is the number of parent atom initially. Okay, it is the initial number of parent atom. Okay, when your T is equal to 0, or you can just call it as T0, like disintegration or the radioactive decay that has not been started. Okay, so here the answer is 2 gram. Okay, so some information regarding this question. I just so when a radioactive parent, okay, when a radioactive parent is disintegrating and giving some daughter, okay, so why, now the thing is, why a parent atom, okay, why it is disintegrating? Because it is unstable. Okay, now it is unstable, so to get stability, what it actually happens, what it actually does, it disintegrates by giving some alpha beta particles and some energy. Okay, some energy. Okay, so this is unstable parent atom. Now this unstable parent atom is disintegrating, and within this disintegration it is emitting some alpha beta gamma or some amount of energy. Okay, some amount of particles, and it is getting its stability configuration. Okay, now this is stable, this is called your daughter element. This is a radioactive parent, radioactive parent, and this is called, this daughter is called radiogenic daughter. Radiogenic daughter. Okay, radiogenic you can just simply call stable daughter. Why stable? Because this unstable parent is being converted to a stable radiogenic daughter. Okay, non-radiogenic stable atoms are also there, where we use the stable isotopes. Okay, stable isotopes. If I just ask you that strontium, okay, this is strontium, let me just change the color so that you will be able to see. Okay, so let strontium is there. Okay, strontium has so many of isotopes. You just watch, or you just search in the Google. Okay, now it has 87 strontium and 86 strontium is also there. Now 87 strontium is there, 86 strontium is also there. Okay, and these two are stable, isn't it? These two are stable, and this 86 is non-radiogenic stable, non-radiogenic stable. Okay, and this 87 SR, it is radiogenic stable. Okay, I'll just write down here, this is your radiogenic stable. Radiogenic stable. And if it is radiogenic stable, then it must have formed by the disintegration of some unstable parent nuclei. Okay, so it is being formed by the disintegration of rubidium. Rubidium, it is actually, because rubidium strontium system we will study. Okay, this rubidium is unstable parent atom. Okay, now it disintegrates to strontium 87, and though this strontium 87 is being formed by the disintegration of a unstable parent nuclei, okay, radioactive nuclei, this is unstable radioactive nuclei, radioactive nuclei, that's why it is called a radiogenic stable isotope. Okay, this is 87 strontium stable, but this is formed by the radiogenic process. Okay, radioactivity. And this 86 SR, it is non-radiogenic stable, it is in nature, that is present, that is stable. Okay, so these are, and this is 2.0, this is our answer in this case. So I hope you just understood this process and some related things like this radiogenic and radioactive. So if you have any kind of doubt, then you can just simply write down in the comment box. And if you like this video, just and do like and subscribe to my channel. Okay, so save our mother earth, always plant more trees, go green. And thank you very much. And if you are interested to join our group, then you can simply just text to these numbers. Okay, any of these numbers, no problem. Simply put a mail to this mail id, or there is a link tree. Okay, there is a link tree given in the description box, and if you just click through it, then it will direct to all our social media platforms available. So you can go there and visit our website also for more information. And thank you very much. If you have any kind of doubt related to geology, simply ask. पूछ लो, ask geology. Thank you.